And to the slides we go. So let's finish up these ones that we were working on before, and then we'll start some ones. So we talked about social media. We talked about cool Python stuff that will help you with your assignment. And now let's talk about just technology in general. We have some interesting things that exist these days that we can discuss. There are plenty of downsides, right, to technology. So I'm going to try and answer this question, like how can we cope with them if bad things happen? And also, how can we just, this is a critical thinking class, how can we think critically about these downsides and hopefully still end up using technology? Who knows? Okay. So probably the first, shocking thing that is relatively recent was that you could now essentially Photoshop a video. Deepfake. Do you remember that coming out back in the day? So you can deepfake a video. You can put, Nicolas Cage's face on everybody if you wanted to. That's apparently the meme that was going around when it first came out. But what deepfake is using some machine learning techniques to discover where a face is in a video and swap it out with somebody else's, even if they weren't there, right? That is unfortunate. This is already a very common thing to do, right? Because when we had images, it's very easy to Photoshop somebody else's face onto an image, and so you couldn't really trust an image because it might have gone through Photoshop. But for the most part, if you had a video of somebody saying something or doing something, that was pretty good proof that they were there, right? Because you would have to Photoshop every individual frame of the video to get it to make it look like that other person was there. And now that's so easy to do. It's so easy to apply deepfake to a video and change somebody's face and have you impersonate somebody else. So now, your security camera footage, it is all at risk, right? Because if you present it to the police, maybe you doctored it now. It's easy enough to do that and change somebody else's face onto your video. Make it seem like Nicolas Cage robbed you or something, okay? So obviously, there are plenty of nefarious things that you could use deepfake for. You could use it for fraud, make somebody's voice sound like them, make their face sound like them, but they weren't there. You could hoax people. You could make up something, pretend like the president is saying something when it's just a deepfake. And then, of course, for the memes as well. Plenty of use there. But have we seen deepfake before? Is this common knowledge nowadays? It is unfortunate. You can't trust a security footage video anymore, can you? It could have been deepfake. It depends on how you do it. If you want to, if you're good enough at it, you can cover your tracks well enough. Make it seem like it was coming from the video feed itself. Yeah. But you do have to be very fancy about it. There's a cat and mouse game, as usual, between the hackers and the good people. Alright, next topic. Wikipedia. I'm sure we've all used Wikipedia before. Wikipedia, the whole point of it, right, is that people can edit the pages. They can add to pages when new information comes out. And so, Wikipedia is the most up-to-date source for most topics because of that. People are adding new articles or updating existing articles every day, and they could add new things. So, I don't know, you have some fancy article, and then some new news comes out, and then people start adding new paragraphs. Right? So the information that you saw yesterday on somebody's page might not be the same as it is today, as well as just what causes that to happen. So news articles, they come out and people cite those on Wikipedia, and so it's always up to date as much as possible, and that's kind of the point. Wikipedia is supposed to be the ultimate encyclopedia, the ultimate news article, a conglomeration of everything. It's wonderful. But that is also its downside. Because anybody can modify a page, you can say silly things, right? I could go to the Clovis Community College Wikipedia page, and instead of our mascot, I could put a picture of my cat in there. Nobody's stopping me, right? Anybody can change it. You can edit your article of choice with silly information or incorrect information, which is unfortunate. So that's sad. Wikipedia does have some automated efforts. They have little programs that are just making sure people aren't writing bad words all over the place, things like that. Easy enough things to notice by a computer. They get rid of those. But sometimes somebody makes such a subtle change that is still inaccurate, and it takes a while for a human to come along and get rid of it. Okay. And sometimes it's left to stay, but like you see citation needed all over the place or something like that. Sounds like it might make sense, but you need to back up everything that you write. So that is a good thing and a bad thing about Wikipedia. And I don't want to deter you from using it. I think we all use Wikipedia, and it's useful for a lot of things, but you should do what every English professor says when you use Wikipedia. You should always be doing your own research. You should actually go to the pages that are being cited by Wikipedia, making sure that those pages are actually saying what Wikipedia said they said. And at that point, it's a good source. It's a good source for primary information. You just got to follow the links. And that is how I encourage you to use Wikipedia. Any questions, comments about that? Have we seen Wikipedia pages? Have we gone to like a page before and had it have something silly on it? It's totally possible. You can also look through. You just go to a Wikipedia page. I don't know. Clovis Community College. Do we have a Wikipedia page? Well, there's two of us. That's right. So yeah, we have a Wikipedia page, and you can see the history of like everything, view history. And apparently it was changed about a month ago. And you can see what got changed. Where is it? Maybe like the diff or something. I don't know where it is. But they added five characters or something, wherever that is. And I don't know how to view it. I think you have to be logged in maybe to see the change. Oh well. Okay. Or diff. I think that's what I want to see. So somebody added, that our president changed, for example. That makes sense. That is not vandalism. But if you just go to normal Wikipedia, you could see on the side, I think it's so small on my computer, you can see recent changes or something on the left here. It's somewhere. Maybe you have to be logged in. But recent changes, yeah. And so you can see a bunch of people editing stuff, and a good amount of these edits are vandalism, sadly. But they get undone. That's the idea there. Here's a silly example that I found. I followed a Wikipedia link on Reddit for some reason to the California grizzly bear, and the very first line on the page had been vandalized, for example. But a minute later, it got taken away. So that is a very common thing. But still, we should trust our Wikipedia. Eventually, it's going to get us the right answers, assuming we do our research. Okay? Any last questions about that before my next topic? I have a bunch of examples, as usual. So, all right, another interesting idea about using computers. Car crash tests. Surprisingly, you can model cars inside of a computer well enough to see, like you can throw them at virtual walls. You can throw virtual cars at virtual walls to test them, which is funny. So the reason you want to simulate car crash tests is because you have to make a car if you want to do a real car crash test, which costs a lot of money and is unfortunate. You have to, just to get your car certified in the US or whatever, you have to projectile. You have to send it into a wall with, with a dummy inside and make sure that they didn't get hurt too badly. Something like that. So it costs a lot of money to do each of these car crash tests. You have to make the car. And maybe you're just trying to design the car and testing out different ideas. You don't really want to do that. So before you get your final idea, it's a good idea to simulate it in software. So you do all these tests, these crashes, in a virtual place inside of your laptop or something. That is totally possible. But there are downsides to that. So it's free. It's a lot cheaper to do car crash tests inside of a computer. But is it accurate is the main question. So you have to model physics. You have to model how metal crumples, right? You have to do a bunch of stuff. You have to model every little detail of every little material in this car if you want an accurate car crash test and get all the information that you need as if you did it in real life. So we can model physics pretty well. We know all of our equations. we've taken a physics class, but we don't have enough processing power to model each atom, for example, of the car, and so it's not perfectly exact. But maybe it's good enough, is the argument. So when you make a software simulation of something that would have happened in real life, you have to make simplifications. You have to model like a 1 centimeter by 1 centimeter patch of metal and do that a bunch of times, for example. And the question is that simplification okay? So there are definitely arguments for and against, and that's what I wanted to get you thinking about. Here's one argument for them. Eventually, they're going to need to perform a real car crash test. So you might as well just do a bunch in software first, because you can do more in software than you would have been able to do in real life. So maybe your car would be safer with all those extra virtual simulations, because you'll settle on a final design that's better than one that you would have gotten otherwise. So that's one argument. But a counter argument to that is, what if the simulation simplifications kind of ruined the output? Like they didn't do a good job at saying what would really happen, and so maybe they made mistakes, and they could have found a safer design if they just made more real versions of their cars and did more real tests on actual walls. So there's upsides and downsides. Maybe you want a little bit of both, but that is surprisingly something we can do in a computer now. We can model car crash tests, and hopefully that's going to make it safer, but it depends on how you view that. Interesting stuff. All right. Continuing along the lines of privacy again, I guess, is if you have a phone, right, and you buy an app, for example, you bought that app from an app store. Most of the time, Google has your Google Play Store, Apple has their App Store. Google, for example, they have the power, and this has been done before, they have the power to remove things from your Android phone. Because they make the software, they make the App Store. The reason that they have this power is so that, just imagine some elderly person that downloads something malicious, and the App Store figures out that particular app was a bad one. They can take it off everybody's phone just to make sure they don't hurt themselves with it. So that's nice, maybe. But the question is that still a good argument? Is that the right thing to be doing? Should we be allowing our software makers to take the software that we got and put on our phones off? So Apple is also in the news about this. Do you remember, I think it was like a couple years back now, during the height of the pandemic, they were trying to, they had some beef with the makers of the game Fortnite. They had an app version of that, and there was some issue with how they were giving their money to Apple, because Apple wanted like a 30% cut of their purchases, and Fortnite said no, and so there was a whole big debate there, and Apple eventually took down Fortnite from the App Store. I don't even know if it's back up. Do we know? I'm not sure. But that is the idea. Apple has the ability to do that. If you bought, even if you bought the game, they took it down, so you cannot download it again if you lose it off your phone.
Very early fall 2020.
Yeah. So pandemic, definitely around those times. Unfortunate. Not sure if it's back, but that is something you have to deal with as a user. You kind of sign those terms and conditions, right? And this is what was in it. So there are rules to put your app on an app store, and if you don't follow them, like you make a malicious app or you don't give Apple the cut that they asked for, then your apps can be removed from the store and also removed from people's phones, which is unfortunate, potentially. Okay? So it's up to you guys, the consumers, to, I guess, argue with your money which one that you want. And that's the idea. So a funny example that I saw on the internet, plenty of irony. You know the Kindle devices where you can buy little ebooks and read them. Amazon they have the power to remove books that you buy from their Kindle store off of people's Kindles, and they removed 1984 of all books, which is very ironic if you have read the book. So that's fun. So yeah, this is a power that companies have because you're running their software. You're using their app stores. Is it right? That's my question to you. All right. We also have the concept of forced upgrading, which is people consider to be an anti-pattern, something that shouldn't happen. But others can argue for it. So Windows 10, for example, yells at you and they want you to upgrade to Windows 11 as soon as possible. I have not upgraded still. This happened before with Windows 8. Windows 8 back in the day, it was trying to auto-update itself to Windows 10, things like that. And so essentially there's a lack of control when this kind of thing happens. Microsoft's trying to look out for you, right? But there's a question of, do you have control over the software on your computer? If Windows is going to update itself for you without your permission, like it's just going to do it, what does that mean for you, the consumer? Is that a good thing? Again, there's arguments for and against. An argument for forced automatic upgrades is for, like, I don't know, my parents or something. If you have software that is old and out of date and you forget to upgrade it, which is a common thing to forget, then people can make exploits for that software. They can make old Windows software and they can hack it easily, right? So maybe it's better to have it auto-update itself so that that never happens to somebody, okay? Arguments against, though, is all about control. So you bought this Windows 10, for example, and it's auto-updating itself, but you wanted to stay on Windows 10. Maybe there are some compatibility issues, I'm not sure, something like that. So you've lost control over the software that you bought, or that was bought for you when you got the computer. That is a loss of control that maybe you should have had because you're the one who bought it. You're the one who paid for it. You wanted that exact version. Okay? Any questions, ideas about that? I think one company that actually does this well of all companies is Adobe. Like, they let you keep old versions of Photoshop on your computer and they don't update it unless you tell them to. Yes?
Just a couple things to say about this. I remember seeing a clip once when Windows 10 was rolling out where some like streamer was like playing a game and then their computer crashed
Oh,
and when
shoot.
they rebooted it was on Windows 10.
Oh, man. That's no fun. Yeah, so that, it should at least warn you. But yeah, Windows is good about just, all right, if you're within the upgrade time frame that was made for you, I'm going to turn your computer off right now.
I have a question.
Sure.
So, when it was still Windows 7 and it was upgraded to Windows 10, you actually shut down the updates. Like, can't you do that on Windows 10 so that it doesn't work with Windows 11?
Yeah, but I think they're better about it now. I never experienced this auto updating, so I can't say for certain. But
Yeah, I always turned off my auto updating so that whenever updates are on my computer, I just select them and then that way I don't have to actually get the extra software that up on my PC.
yeah, I think there's people who are much less tech savvy than you that don't know where that feature is to turn off.
No, I'm asking like, does Windows still have that feature? Like,
I think so. I mean, I haven't upgraded to Windows 11 on this computer, so it's definitely possible. But it keeps like saying, it kept saying in the notifications bar, "Hey, do you want to update? Hey, do you want to update?" Something like that.
Oh,
But I just kept clicking no. So yeah, that's fun. Any other comments, thoughts? It's just weird stuff that I want you to have an opinion on. This is why I'm telling you about it. Get your critical thinking caps. All right. Yeah. Just to end off these slides, because we have some new ones to do as well. Let's talk about equity. Do we all know what equity means, by the way? Like, this is the standard picture that teaches you what equity means. And it's important to know the difference, equity versus equality. When you are equitable with people, you are making sure that they get the same experience, right? That's kind of what the college is doing. It's trying to be equitable so that you can check out a laptop, check out a wireless router if you need one, so that everybody has the same tools to succeed in our classes here. So that's an equitable place. But equality is a bit different, right? You see the picture difference? It's like prop everybody up the same amount when some people didn't need to be propped up. That's the difference, okay? Equity versus equality. Equity is better. So let's talk about equity in technology. So again, something good that we do here at the school is provide equitable technology to people, I think. But you can imagine there's plenty of people who don't go here. Yeah. So a lot of low-income households, for example, they don't have access to a fast internet connection. They don't have access to a strong computer. And those kinds of things nowadays are kind of required if you want to like apply for a job, have a Zoom interview, because nobody wants to do it in person anymore. All of those things, okay? So if you don't have a phone or an email address, for example, you're not getting an interview. So you have to be on the internet. You have to have a cell phone, for example, okay? That is unfortunate. And so maybe we should be helping people get these things. During the pandemic, maybe we're still in it, it's extra important, right? Because you needed a webcam to take your silly proctored math tests because you couldn't come into class. That was unfortunate. That's no fun. One last issue, again with equity, is a lot of software is written and tested by the people who wrote it, who are predominantly white people, unfortunately. So hopefully that's going to change a bit as I teach you guys and you become software engineers. But even if somebody gets that cool technology that was created, like they get their Zoom interviews, they get their webcam so they can take their proctored tests, it still might not work for them because it wasn't tested on people with their skin color, for example. It's unfortunate. And so here's a fun tweet. I'll let you read it about a test proctoring software. So this should, hopefully, if you guys ever become software engineers, you can take this into account when you write your software. It is very important. All right. Any questions about this or the rest of these slides before I start some new ones? We want our software to be equitable. Okay, so let's keep on trucking. I have just a few slides. We won't go through all of these, but I want to talk about issues with computers specifically, and then just bugs, because those are technically issues. Let's talk about some famous bugs. We'll talk about the Therac 25 as well. So here's failures and risks, oh my. So I think we've seen enough in the news, like bad things happening, and computers were involved. So I'll try and help you answer this question to yourself, like how do we still use computers when they cause so many problems? The answer is they still improve our lives, don't they? So let's talk about some issues, though, some bad things. The first one, the most, I don't know, the coolest issue, I guess, because it blew up, was the Ariane 5 rocket. This was back in 1996, and this was a rocket made by not NASA, but, oh no, go over, not NASA, but ESA, which was European Space Agency, I think. It was the European side of space, and unfortunately, this Ariane 5 rocket, it blew up as it launched, sadly. It wasn't the first, like there were Ariane 4s before it, but Ariane 5, the first version of it, the first launch of it, went very badly. It self-destructed because it thought that something bad happened when it didn't, and this was back in 1996, only after 37 seconds. So like it blasted off 37 seconds later, it decided in its software that it should self-destruct, and so it did that. Nobody was on the plane, the rocket, thankfully, so nobody got hurt. But that's what happened. Yeah.
Question: is it like literally self-destruct? Did the rocket really have a function to blow itself up, or did it just do something that caused it?
That is a good question. I believe that was a failsafe. Like we're going to stop ourselves right now. I don't know if it just turned its engine off or if it blew up. Let's look that up.
And like usually whenever a rocket is built, it actually has a self-destruct sequence built into it, just because if it flies into a populated area, so that it can actually do less damage.
So it legitimately knows how to blow itself up, like boom.
Yeah, just in case anything actually happens.
All right, and that, I guess maybe it makes sense to destroy yourself up in the air,
You know that.
rather than. Do we have? Oh, Wikipedia is new now.
Yep, footage.
Yeah, let's see. Ariane 5 explosion. Software bug. Do we have a video of it? Let's take a look. We know how fast the internet is for my laptop, so we'll see. Does it actually blow up? They're just talking about what happened. Yeah, it looks like it legitimately self-destructed. So yes, I was right to write that. Come on. Yeah, so it just told itself that, oh no, something bad happened, we should blow ourselves up. And it legitimately blew itself up. So that's fun. We can watch that some more ourselves. But I'm glad we know. So yeah, the issue, 37 seconds into flight, it thought that something went so horribly wrong, it told itself to blow up, and the cause of this issue was a software bug that could have been prevented. Ridiculous. So funny. And so this was $370 million in 1996 money, and that's what it cost to build this thing, and they lost it all after 37 seconds and one line that was wrong of code. Unfortunate. So let me try and describe to you the problem, because you can more or less understand the problem right now with your current knowledge of Python and stuff. So what they did, and number systems, they tried to shove a 64-bit float number, one with decimals, into a 16-bit int number. And we know what all those words mean, so let me try and talk to you a little bit about it. So they had some number that represented what was called the horizontal velocity of the rocket. And that was a 64-bit float. So it was 64 ones and zeros. 0, 1. This is a 64 binary digits. 64-bit digits. 64 bits. And they tried to put that into 16 bits. Which, I mean, if they rounded it, if it was within a good range, that's okay. Like, you're allowed to do this, but you're going to lose some information. They tried to put this number into this number, and it didn't really work out. So, first of all, the 64-bit one was a float, and it was able to represent, remember what the float type can have inside of it? Floats can store decimals, 3.14, I don't know, they can store like large numbers as well, like 5 times 10 to the 40, things like that. That is all representable within the float type. Ints can only, though, hold whole numbers. And they have a certain range, like just do 1, 1, 1, 1, 1, 1 16 times, you can figure out what the biggest int could be in 16 bits. You know how to do the conversion, but ints are just whole numbers. Could be negative, though. And so they tried to put a 64-bit float that had decimals into a 16-bit int, so maybe they rounded it, but it didn't have enough room. It was bigger than what this could fit. It overflowed, we said. Okay? And this number was meant to represent the horizontal velocity of the rocket. And let me try and draw what that means. Like, here's what I believe horizontal velocity means, because it's always relative to something. Let's assume it's relative to the Earth. Here is Europe. I don't know, there's Spain, Italy, blah, blah, blah. The UK, boop, Ireland. And so they launched this rocket, and it's coming up into space. Here it is. My best drawing of a rocket. And there it is. Horizontal velocity is like, you pick an axis, maybe it's like some certain latitude line where it went off. It's like how fast it's moving sideways relative to Earth. That's essentially what horizontal velocity means, I think. And so they were trying to store this number. They took it from here and they were trying to shove it into 16 bits. And unfortunately, it was moving maybe at an angle so fast, it was going very fast horizontally relative to Earth, that the number overflowed, we say, the amount of things you could put in 16 bits. And so once you overflow, you can't represent it exactly, and weird things happen. So maybe it like zeroed itself out because like it was supposed to be like 17 bits that had a 1 and then a bunch of zeros at the end that meant something big, but like the 1 got chopped off, and so now it thinks it's small. And so I don't remember the full story, but assuming that happened, maybe it thought that it was moving so slowly that the rockets failed. Something like that. And so that's why it thought that something bad happened, and oh no, we cannot continue, let's stop. All right. The reason for this bug was that they reused code. they reused code from their Ariane 4 rocket. And back then, when they were writing that code, they didn't think, like they did the same thing, putting 64-bit floats into 16-bit ints. They thought that the horizontal velocity reading would never get that large. But Ariane 5 had more power, had more thrust, and that is why it overflowed. So let's talk about overflowing just a little bit more. So for example, if we had a 4-bit number, if we were trying to shove something into a 4-bit number, the smallest 4-bit number is 4 zeros, that's just the number 0. And the largest 4-bit number is 1111 in binary, which is the number 15 if you do the calculation. Once you have, assuming you can only put numbers in 4 bits, the second you have the largest number and you try to add 1 to it in binary, what happens is that it's just going to do this thing called overflowing. 1 plus 1 in binary is 2. Let me try and teach you binary math. 2 in binary, though, is 1 0, so you have to carry immediately. 1 0. And then again, we have 1 plus 1, 1 0 in binary. We're doing binary math. This is binary answer. 1 0. Again, we have 1 0. And then this again is 1 plus 1. That's 1 0 0 0. And if you don't have room for this extra bit that you need, there's now a 5th bit in the answer. It's supposed to be this as the final answer that makes it 16. If you don't have room for it, it overflows and it just says it's 0, which the big number that it should have been is now such a tiny number. And that was the problem. That was the bug. Okay? Any questions about that? It's a weird one, but it was like a couple lines of code. Cost $370 million. Yeah, it's a very expensive flight. Isn't that fun? All right, questions or comments about that? I have more examples of bad things, of course. Let's see here. All right, let's talk about voting, because that's something that's going to happen eventually. Again here, voting systems, they can be electronic. California is kind of good at only doing it with paper because they don't trust electronics. But some states use electronic voting. Some countries like to use electronic voting. From the textbook, here's an example. Back in the day, some electronic voting systems crashed. And so the people who came to the polls to vote, they were not able to vote. That's not good. That could have changed the election, couldn't it? So that's no fun. Another example of voting systems going badly is one county who was trying to collect votes on voting day, on election day. They lost more than 4,000 votes because a certain machine that everybody was using had its memory full. It couldn't store any more votes inside of it. That's no fun again. Luckily, they noticed it, but this is not good, right? In one county, in Texas, they had voting systems that were electronic, and a bug in the voting software generated 100,000 extra votes for one of the people. I think they noticed it because of the population differences, but still, that's not fun. So bad things can happen if you're voting electronically. Another bug, this is probably the worst of them all, is caused some candidates to receive votes cast for other candidates. So you press one button thinking you're voting for one person, and it really votes for the opposite person, and vice versa. Or maybe not vice versa, which is even worse maybe. So that is a problem. Once you have electronic things, or stuff you really care about, like voting, bad things can happen. You can have bugs, and the outcome is not good. So you really want to make sure this stuff doesn't have bugs. Yeah. But it's hard to do that. It's really hard to make sure that everything doesn't have bugs. So I think one thing that you have noticed by now, writing all the programs that I've asked you to write in this class, is that you usually don't get the right answer the first time. Right? You make mistakes. We all do. And your program isn't immediately correct. And it's hard to write a program the first time that is correct or safe, that is untouchable. But there are ways to gain some confidence in your programs, and I'll talk about that in a second. Some places, they have enough confidence. They tested it out enough. And in Estonia, for example, their elections are completely online. Log in on a website with your social security number, whatever their equivalent is there, and you can vote online for the election. And that may be just a cultural thing. They didn't have as many problems as we had, and so it's okay for them. Isn't that fun? So yeah, these important things, they better be checked, made sure to be correct. All right, and that leads us to one of the topics, to the topic that is on your next essay, right? The Therac 25 machine. So I hope you've read the article by now, but if not, let me at least explain it to you now. So what was the Therac 25 machine? It was a radiation therapy machine for people with cancer, right? You're going to send radiation directed at somebody's cancerous cells, and hopefully that radiation would cause them to die, and the cancer would go away because of it. So that was a nice machine to have. And this one was made in 1982, so back in the day, quite a while ago, it came out the first time, and there were problems with it. This is not good, of course. The first documented accident that happened with the Therac 25 was in 1985, and you know that there had been more undocumented accidents with it before then. So that is no fun. It's a very, very sad story, not fun to talk about, but important to know so that we don't make these mistakes ever again. So, yeah, no fun at all. There was, again, an error. There was an issue with the code. So this error had to do with both the code and as well as the design of the machine. What it ended up doing was giving people up to 100 times the amount of radiation that they were supposed to get. So there was, I don't know, here's my best drawing of a radiation beam. So you turn this thing on, and it's meant to send radiation at somebody. But when you're setting it up, it needs to be turned off, right? So there used to be a hardware shield in front of the Therac 25 when the operator was changing some stuff about it, like it was lead and it wasn't letting any radiation go through. So the previous versions of the Therac 25, I think it was called the Therac 20 or something like that, it had some hardware systems to block excess radiation, just in case bad things happened, okay? Like this little shield thing. And they were trying to cut costs on the Therac 25. They obviously had no issues with the old version, so they thought that their software was good, that it was okay, and they didn't need this radiation shield anymore. But unfortunately, there were times when the machine was spitting out a lot of radiation that the hardware shield was catching, and they didn't know about it. So when they took it away in the new machine, it was now giving people way too much radiation, and it's really, really sad and ironic, of course, because the machine that was supposed to cure people of cancer was giving them more cancer. That is no fun at all. So that's the Therac 25 issue in a nutshell. Are there any questions or comments about that one? We read the article, read the essay. So I'm interested in hearing what you guys have to say in your essay, at least. But before that, I think they were the previous versions that the Therac 25 was based on, but I could be backwards.
Yeah, I read that in the Therac 25 they had recalled it, and then they actually relaunched it as Therac 20, and then they didn't fix anything. They just rebranded it and then sold it again.
Interesting. Well, I'm glad they at least fixed it. Yeah.
No, they just rebranded it and they just renamed it and then sold it back again to the companies, and they had to recall back those products.
Oh, that was the one that they recalled. I see. Yeah, that is unfortunate. It's a very, very sad story all around. Bad things happened, and so yeah, I'm excited to listen to you argue why that was a horrible thing in your essay. All right, so I've talked about a bunch of bad stuff. I have now a little debate question for us. Let's see here. I won't put you into even odd things, but please get together with the people next to you, and I'd like you to go to the written ice page, please, and I'll clear it out for us. Whee! There it is. So, there we go. Here is a debate for us to have, and I'd like you to work together with the people next to you and get some stuff in. You can just type it all in one response if you'd like. Is it the programmer's fault when something bad happens? When there's a bug in the code and something bad happens, and it was like the Therac 25 machine, it was the Ariane 5, but people were inside. When there is a bug and it hurts somebody, Whose fault is it? Is it the programmer's fault? Because they're the ones who wrote the code. So you tell me. Please try to come up with one argument for each side. So an argument saying that, yes, it's the programmer's fault, and here's why. And an argument saying, no, it's not the programmer's fault, and here's why. And I'll share my thoughts as well once you share yours. Okay, so that's the debate. I'll give you some time to think about it and get some responses in. I'll look up the theory while we're talking. I haven't read the article in a while. Okay, yeah, so the earlier units were called the Theric 6 and the Theric 20. Those were the earlier ones. One minute. All right, one more minute, and then we'll talk about it. All right, that's my timer. Let's take a look at what we're thinking. Thank you for getting your responses in. So, all right, it's their fault. Yes, because there should have been a test. Somebody should have tested it. Maybe the program should have tested it. So that's one way to say yes, it's their fault. Maybe it's not their fault because, yeah, maybe there was some side issues. Maybe it was the material's fault. That's a very good way to argue that maybe it wasn't the programmer's fault. It could have been some other factor that they did not control. Okay, all right, it's not their fault. Some machines are prototypes, purely theoretical. That's true. Maybe somebody was working on something and they didn't know it was ever going to be used on a person. Like you're using somebody's software from a research prototype, and somebody should have changed that. Okay, so that's a possibility. Good, good, good. It's their fault. If it can be traced back to being faulty. I'd want to hear more about why, though, because that's a bit circular. It's not their fault. They might receive a product. Yeah, maybe it was the materials. Maybe it was the components. Good, 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 good. All right. Any other thoughts about this that you'd like to talk about? Yes. Oh, shoot. Could be a bug in my system. No clue. Sorry about that. Something looks like it just changed. But it tries to auto-update. I'm not sure what's happening there. Sorry about that. There's a bug in my code, obviously. Oh, cool. Oh, sweet. Thank you. Yeah, let's take a look. Yes, so one reason for if it's the programmer's fault, so it's them. Yeah, if they didn't write it, it wouldn't have happened. Good. That's a good way of thinking about it and assigning blame. Yeah, testing is the idea. So they should have been more careful. Could be their fault. That's one way to argue. And then yeah, everybody makes mistakes. We've all written programs that have been faulty. Very good. So you don't have in your mind all the different possible ways for something to be used. It's just hard to plan on. You send your software out to everybody, and maybe they find something that wasn't meant to be there. Like people hacking video games, for example, like going through the walls. Like that wasn't intended, but nobody thought to try that, but people figured it out. That's exactly right. So yeah, great ideas, everybody. So yeah, let me talk about a few of my ideas, and then I'll show you one way of gaining confidence in your code. So, all right. So yeah, there's always, the question is, how do we assign blame? And I've had you think about that in your minds. But one thing that I do have to say is that I don't think we fully understand, because I've asked you to write code individually in this class, but when you get out into the real world, people are working in giant teams on tiny little bits of software. Like you have a giant team that's working on the PowerPoint program, for example. And like some people are touching like the text stuff, some people are touching the image stuff, some people are touching the little thumbnail picture stuff. Like everybody's working on something else. And so most of the software people, they don't, like they have their little thing that they're working on. They don't understand what the big picture is, first of all. That's one counter argument to like it's their fault. And just again, like I said, it's very easy to have a bug in your program and not notice it until much later down the line. Okay, so those are the problems. Like they're never going to go away. There are some solutions though. Testing and verification is a very, very important piece of industrial software engineering. If you want to write something and give it to a customer or a client, you better test it. Or you can do some hardcore verification stuff to ensure that it's correct. Okay? So you have to make sure that it all works out. And just like if you look these up, these might be next to each other in a thesaurus. But testing and verification are not the same thing. They don't mean the same thing in computer science. So let me tell you the difference. So testing is when you write little small chunks of code that are called tests, and you make sure that the output was what it should have been. That's what a test is. But sadly, it's something that people don't like doing. But I force my CSCI 40 students and above to test their code eventually. So the way that a test works is that you have your code and you treat it like a black box. What you do is you send information to it. You give it the inputs, like maybe you write something that takes 2 numbers. Your program takes 2 numbers. You give it those 2 numbers, and then, I don't know, maybe the second number is 43. And you check, or maybe it just takes 1 number. Let's just say it takes 42. And you check that that gives back the right answer. You run the code in your mind. What should have happened maybe is that the answer was 13. And you make sure that your code, when you really run it, it gave back 13. And then you do this for a bunch of inputs, like try it on the number 43. And now make sure that it gave back the right answer. Maybe it's supposed to be, 33 for this one. But you saw 34, and so it didn't work. So you tested on a bunch of individual things to make sure it did the right thing. So that's what a test is. Specifically, this is called a unit test, testing a small unit of your code. So here's an example. And a test is itself a program. It's like, all right, try the input 42 to our program and check, make sure that the output is what we thought it should be. Confirm. With like an if block or something. Confirm that the output is 13 or whatever it should have been. Like this would be a second test. Take the 43, confirm that the output was 33. But apparently it wasn't. That's what a bunch of tests are. And if you make enough of these, you can gain some confidence in your code, right? So that's what you want to do. That's called testing. And just to drive the point home, before we talk about verification, that'll be next time. That's more hardcore. Testing is pretty easy, and I can explain it to you, and we can actually do it together. So let's go to Scratch, because why not? I'll make a program. I'll make a multiply all the numbers from 1 to n block, okay? And then we'll write some tests for it. That'll be fun. So I lied when I said we're never going to do Scratch again. This is probably the last time I go to Scratch, because we don't know about how to do if-else in Python yet. So, yeah, let me make a program. Let me make my own block, and that will be the thing we want to test. Let's make a multiply the numbers from 1 to n block. It'll look like that. I'm going to make a new block. Multiply the numbers from 1 to, and then I need input. Input can be called n. All right, and let me just write the implementation of this very quickly for us. It is very similar to adding all the numbers from 1 to n, which I've shown you before. Let me make a variable called product, and I'll make a variable called, I don't know, let's see. Can't call it n. What could I call it? I guess I could call it x. But maybe do I need to change? Yeah, I need to change n, darn. I like the variable n so much, I'm going to change maybe this one. Delete block. Multiply the... Or actually, I'm going to try. Let's try keeping this one called n and then the variable called n. It might be possible to have both. Here's an orange variable called n, and here's the red n that was given to our block. 2 different n's. Let's see if that works. And the goal of this is going to be, here's the setup. I'm going to make a product variable. Like if the user wanted to multiply all the numbers from 1 to 4, for example, this is what I'm going to do. I'm going to make a product variable, start at 1 because I'm going to multiply stuff into it. I'm going to make my n variable, set it to 4, which is the input. How about I call the thing in the block x? That would limit confusion. Multiply numbers from 1 to, and I'll call it x. I'm happy with that. And so I'll put x into n at the start. So this will start out at 4, then I'll just keep multiplying 4 into the product, decrementing n, keep multiplying n into product and decrementing n. Now I'll multiply 3 into product. 4 times 3 is 12, decrement n, bring that in, multiply it into product, now it's 24, decrement, now it's 1. This doesn't change anything, so I could have stopped, but multiply 1 into 24, and now it's still 24. Decrement n, now when it's 0, I do not want to multiply 0 into product. I am done. So that I believe will be the strategy. So I'm going to set n to the x that I was given, and I will set product to 1 at the start, and then repeatedly until n becomes 0. I want to do this repeating, multiplying and product decrementing n. So until n is 0. So repeat until n is 0. I need an n, I need an equals check. And so I want to repeatedly, let's see, I want to set product to product times n. And then I want to decrement n, like I said. Change n by -1. Something like that. And then, I don't know, let's just, maybe we can say the answer or something. And the answer is going to go into the product variable. Like it's going to be the 24 at the end of all this. So that's what we want. So let's output product for 2 seconds. I don't know. And so here's me using the block. I can just like call it, put it right here, be like, multiply the numbers from 1 to 4, please. And then he says 24. Okay. And so that's the block. Let's write some tests for it. Okay. Let's write some tests for this block. And so a test is just, you write it here, and then you check. You check that the answer was what it should be. So like this comment should be, when we run this block, we should say that should be 24 as the answer, right? That's one test. You run it, and you check that it was exactly what you thought it should be. You can use an if block for this as well, if you just check the product variable or something. Something like that, okay? That's one test. But we could make multiple tests, can't we? We could say, all right, tests are good to make sure that it's correct, and so we should be testing every possibility, especially the corner cases, where things are almost gonna, like, we're gonna go through the loop just once, we're gonna go through the loop 0 times, almost correct or not correct at all, okay? So a corner case, a good definition of that is like when the program is right about to do something different, okay? So some good corner cases are like multiply all the numbers from 1 to 1. Because that should work. It should give back 1, right? All the numbers from 1 to 4 is 24. All the numbers from 1 to 1, that's just the number 1, so it should give back 1. It shouldn't mess up. Multiply all the numbers from 1 to 2. That's another good corner case. Like, all right, that should be 2 times 1, which is still 2. Make sure it doesn't mess up. That's like it only runs the loop once, twice. What happens if you run it 0 times? Let's see. So that's one test, another test, 1 to 1 should be 1. Multiply all the numbers from 1 to 2 should be 2. So these are just tests. We write the code, then we make sure it's what we thought it should do. It does what we thought it should do. Like this one, yes, it does do 1. This one, yes, it does do 2. So these are 3 tests, and they're working right now. So we say they're passing. But there are, of course, cases that don't work right now. Okay? There are some bad, just test the very incorrect cases, things like that, like -42, or even 0, right? 0 is going to have it not work. Repeat until n is equal to 0. Watch what happens. First of all, we need to decide, like, what do we want to see when the number is 0? Multiply all the numbers from 1 to 0. What should happen? Like, this should be an error, right? There are no numbers from 1 to 0 in that order. Error? Should have an error message. And so that could be our test. Because right now, when we run this code, watch what happens. It sets, I don't know, n to x, repeat until n is 0. It says 1. It doesn't go through the loop at all. But it says that the product is 1. All the numbers from 1 to 0. Which doesn't really make sense in the first place. So that's an error. Duplicate. An even worse error would be like 42. Or -42. Multiply all the numbers from 1 to -42. If you follow this code, what's going to happen? It's going to set n to -42, product to 1, And until n is 0, it's going to make, multiply into product, it's going to make n negative 43, negative 44, negative 45. It's never going to become 0. That's going to be an infinite loop. This is why we write a bunch of tests. So I click this, just watch product zooming around. N is just getting smaller and smaller. It's not a good time. So that's an infinite loop, and that should also have had an error message. So those are the kinds of tests you want to write. These corner cases, and then some normal cases like n equals 4, etc. Things like that. Okay? ... But the whole point of a test is that you compare what you got, what the program actually did, you look at it, and you compare it with what you expected to see. You have to run the program in your mind. That's the goal. That's the idea. Okay? So that's what we've been doing. These comments are essentially us running the program in our minds, like this we should see 2, and yes, confirmed, the test passes. This one should be an error, this one should be an error, and so I believe this last one's an infinite loop right now as well, so that's a problem. So I believe the way to solve it is, all right, if x or n, depending on how you want to do this, if x is 0 or less, we don't want to do any of this. We should stop, okay? Something like, I'll just be lazy and do like an if here. Oops. Like an if up here. If x is less than or equal to 0, or gosh, I would have to do an or, because they don't have a less than or equal to block. So let's say if x is less than 1, strictly less than 1, then it's 0 or smaller, then we should say an error. And it is. Say, can't multiply up to a number smaller than 1. Something like that. I don't know. But again, this is not yet complete, is it? This is, let's move these down. I mean, it'll work for the normal cases. It will just not get to the error case. But if x is less than 1, it's going to say all this, and it's going to continue. You see? So in addition to saying error, it's also going to say an answer, or it's going to say error and then get into an infinite loop. So we should make sure that never happens as well. And that is, again, part of the test. You update the code, see if the tests all still work. And so one way to make sure that never works is, never continues, is just say stop. Stop everything once, if we ever get into this error case. So watch out for that. Otherwise, do the normal thing. The normal thing is the rest of the code down here. All right, so if there's an error, say it and stop. And I believe that will work out. Like this is going to be all the normal tests passed still, but now like 1 to 0, error message, and that's it. Stopped. This one, error message, no infinite loop. It stops itself. Good. Okay, so those are tests. You run the code in your mind, you determine what should happen, and that is that. Any questions about what a test is, what it means? If you wanted to get fancier, if this block was able to actually give something back, I guess you could check the product variable, but normally you'd write the test that would be a program itself. Like you'd have an if block, like if the answer is not equal to error message, then the test failed. Otherwise it passed. Something like that. But these are examples of tests. Compare what you expected to what you actually got. Okay, and there's the code again. That helps you write the code as well. That helped us notice that we needed these checks. Any questions about that? One idea, though, is like, when do you stop? When do you know if you have written enough tests that your program is correct enough? Because like the user could put anything here. Maybe if they give the number 512 or something, everything goes wrong. How would you know that if you didn't try it? So there are ways to come up with a good number of tests, but kind of what I said should make sense. Got some corner cases, very incorrect cases, and then some normal average cases that you would expect to see the user who's not trying to break your program use. Things like that. It's always compare what you got with what you expected. Okay? So those are tests. Write as many of those as you'd like, and that would help you gain confidence in your programs. All right, I think that's what in the slides where I want to stop today. Any questions about any of what we've been talking about? All right, let's take a look and see if there's anything I need to assign right now. Yes, so there is going to be an essay due this week, so I need to give you another essay. So let me do that. This one will be due week 12. So we are in week 10 right now. This one will be due week 12. So let's talk about it. This one is your biggest essay yet, because there are some interesting things that I want you to do. This is going to be a 1,000-word essay. We have to get to 5,000, unfortunately, for both of us. So that's a requirement. Let's talk about this one. All right, the first thing, I can't give you all of these instructions. It's just too many words. So I need you to read all of these directions from start to end. There have been students who did not read the directions, and they got a very low score because of it. So this is very important that you do exactly what I tell you to do, okay? So read these instructions, very important. What I want you to do, remember we talked about fallacies? I would like you to find fallacies in the wild. You're going to be looking on social media. So like you'll go to Facebook or Twitter or some fun place, and you will look for fallacies there. So here is an example link to a list of fallacies on the internet. There's a Wikipedia page about them. You can find any one you want, including these, the ones that we talked about in class, as long as you argued like, yes, it's called this one. So you can find any of them. Pick whatever topics you like. It doesn't really matter. But here are some examples that you can search for on Twitter, for example. But here are your main directions. I want you to write an essay of 1,000 words with this structure, okay? I want to see, of course, an intro paragraph and a conclusion paragraph. But the meat that I want to see is I want to see multiple paragraphs, at least 5, one for each fallacy you found, each doing this. I want you to quote a post that you find on social media, so like a tweet. And I want you to say, this tweet has this particular fallacy. Like you have to say the name of it, right? Like this is a straw man fallacy, and here is why. Okay, I want you to argue why. So the 1,000 words shouldn't be too bad because you're going to be quoting people. So that's not going to be an issue, I hope. But I want you to quote a post. You're going to find at least 5 separate posts and analyze why they contain a fallacy. Tell me the name of that fallacy. You can find whatever kind of fallacy you want. And that's what I want you to do. Are there any questions about that? That's going to be your main job there. Let's see if I have anything else I want to say about that. Any questions about those instructions? Those are probably the most important instructions. You're going to have 5 separate things that you find on the internet, 5 separate tweets, like something like this, but that contains a fallacy. And you'll tell me about it, okay? For example, I think I gave you a tweet with a fallacy in it, so that's the kind of thing that you'll be looking for. Let me go back to that lecture, because I just want to make sure we're all on the same page. We'll all get full credit. So here are our fallacies slides. Remember that crushed ice I gave you once? It was this one. This was a tweet, and it had a false dilemma fallacy in it. So that's the kind of thing you'll be finding on the internet. So people are wrong all the time on Facebook, on Twitter. I want you to find 5 examples of people having fallacies in their arguments, okay? So I want you to find 5 fallacies in any social media post, Twitter, Facebook, Instagram, comments, whatever, TikTok. The last requirement that I want to give you, though, is people say mean things to each other on the internet all the time. Those are ad hominem fallacies. Those are so easy to find. I do not want your entire essay to be you finding a bunch of ad hominem fallacies, okay? So you're only allowed 2 max ad hominem fallacies. The rest must be other things, like straw man, false dilemma, stuff like that, okay? That is the bulk of your directions. Are there any questions about it? You're finding 5 separate fallacies in posts on the internet somewhere. I'm excited to see what you find. This is one of the most fun essays I get to grade. Just find all the ways that people are wrong on the internet. But yeah, format in any way. I would like to see the quoting posts and fallacies and their analysis. Okay, remember that you can't just say this has a fallacy and move on. Every fallacy has a name. All right, tell me the name. Argue to me why it has that exact fallacy. All right, 1,000-word essay. You have a few weeks to do it. I think that's everything I wanted to say. Any questions about that? Please read the directions. All right. So yeah, that is all that I have for us today. The rest of the time is yours to work or ask me questions.